Alright, Trig people, got a great video for you today. I'm sure you'll be excited about it. I'm going to start out by reviewing a little bit with our cosine wave. I know certain people are very fond of graphing. You know who you are. Now, the cosine wave, remember, as we talked about from the unit circle, if you just take a look at it, think about it, cosine starts out at its highest value at 0. At 1, and then it goes down to 0 and then down to -1. Remember how we talked about how it repeated the pattern after 2 pi units. We found the bottom of the wave, and then we could find the other individual parts. And we know that it's going to do the same thing on the other side. So we'll have this similar looking shape forever and ever and ever, right? Something like this. Well, anyway, what's the domain of that function? Hopefully you're all telling me all reals. And what's the range of that function? Hopefully you also know that that's from -1 to +1, which can be written with the closed brackets, or it can be written in its other form with the interval notation. Is the inverse of y equals cosine theta a function? Is the inverse? Well, my first thought was, hey, does it pass the horizontal line test? Nope. All right, so the inverse is not a function. Because y equals cosine theta fails the horizontal line test. Okay, so we got that information. Because we know that if you switched x and y and were to regraph it, you would get something. Let me see if I can do this right. Switched x and y, you'd get something that would have looked like this forever and ever. Okay, clearly not going to pass the vertical line test, right? Going to be a miserable failure there. So, we want this thing, the inverse, to be a function, which means that the only way we could do that is if we restrict the domain of the original cosine theta function. Restricting the domain, that's a fancy term for chop most of it off and throw it away. Now, if we're going to do this correctly, there are a few criteria we have to follow. First of all, we've got to choose quadrant 1 because we deal with a lot of angles and that are in right triangles. So we are not going to get rid of 0 to pi over 2. So we are going to definitely keep 0 to pi over 2. The functions need to have the same range from -1 to 1. And the last criteria, it needs to be connected or continuous. So let's take a look at my options up here. So we are definitely keeping this section right here from 0 to pi over 2. That is an absolute must. Now, let's just suppose I choose from -pi over 2 to +pi over 2. Does this have the range that I'm looking for, -1 to 1? Well, clearly we can see that it does not have the same range. It goes from 0 to 1, so that's not enough. Okay, so let's start over. Okay, I've got from 0 to pi over 2. Let's go to the right a little bit. So 0 to pi. This does have the correct range from -1 to 1. So I like this piece right here. So this is my restricted domain for the cosine wave. So in other words, if we restrict this thing, and I don't know where I'm going to put this. Let's see here. Let's talk about it right here. if we restrict the domain, the graph of y equals cosine theta, if the domain is from 0 to pi, okay, so 0 comma pi with the brackets on the ends, okay. Now what's that going to look like? So the cosine wave, which we saw a few minutes ago, started out at 1 and it went all the way to pi. So in other words, started here and ended here. This is the piece that we're dealing with, okay? That's what we have just restricted it to. So now we have a domain that goes from 0 to pi, but we still have the range that we wanted, which was from -1 to 1. So we're happy. And I'll show you why in a little bit, okay? But at least we follow the criteria, and we have a piece such that when we graph the inverse, see how this passes the horizontal line test? That makes me happy, so that when I find the inverse, its inverse will be a function. Okay, so let's do the same thing now for the sine function. We know that the sine function had a pattern that looked like this. Still a period of 2 pi, amplitude 1, just like we talked about. HK is on the center line on the way up as you move from left to right. Okay? So, domain, all reals, yep. Range from -1 to 1. Is the inverse of that a function? No. Okay. For the exact same reason we wrote down before, if this fails the horizontal line test, therefore the inverse will not be a function. It's going to do the same type of thing. It'll fail the vertical line test. So we're going to do the same type of restrictions. Here, let's walk through that. We're going to start with the first quadrant, 0 to pi over 2. We've got to keep those. If we do the same thing we did before with the cosine wave and move to the right until we have from 0 to pi, we got a problem because this doesn't have the same range. Okay, and we want to keep the same range. So we'll start over again. Let's go back here and expand it out to the left and go from -pi over 2 to +pi over 2. Take a look at that. That has got the right range, -1 to 1. All right, so that's what we're going to do our restriction on for the sine function. Okay? So what does my graph look like for if we restrict the domain from -pi over 2 to +pi over 2? Okay? Or like we said, -pi over 2 is less than or equal to y, which is less than or equal to pi over 2. Okie dokie. So here's what we have restricted it to. We've got -pi over 2 on the left and +pi over 2 on the right, and a -1 here and a +1 there. And so we restricted it This passes the horizontal line test, so I'm a happy guy, you know, because my inverse is going to be a function, and I like that. All right, now, graph the tangent. Let's take a look at the tangent function. The tangent function, we know, has a period of only 1 pi, and at all of these odd multiples of pi over 2, we keep getting these vertical asymptotes, right? You know, and the shape comes through right at the increments of pi. And we can graph these forever and ever and ever, but we're not going to. What's my domain? All reals except odd integer multiples of pi over 2. And my range, definitely all reals. Now we'd like to keep the same range, but is the inverse of tangent a function? Definitely not, right? Right there. Fails the horizontal line test. So same result as before. So if we do our restrictions like we talked about before, we definitely want 0 to pi over 2, because 0 to pi over 2 has the angles for the right triangle. But if I go over to here, right, 0 to pi, just like we did with cosine, I see that it's disconnected, and we want it to be connected. I mean, it looks like I cover all the values in the range, so that's not a problem, but we're disconnected. I just don't like that. So we'll go back here, and we will use from negative pi over 2 to pi over 2, but we won't include the endpoints, right, because those are vertical asymptotes. But that's what we're going to restrict the domain to. So we're going to chop off most of that and throw it away. So if we take what does the tangent look like if the domain goes from negative pi over 2 to pi over 2? I want you to notice that I'm using the open parentheses to indicate we are not including the boundaries. Not including boundaries. Another way to show that negative pi over 2 is less than y, which is less than pi over 2. No equal to signs there, folks. That's because those boundaries are undefined. And so what does my graph look like? Well, it's got a boundary on the left and a boundary on the right. Those obviously are at the pi over 2 and negative pi over 2 marks. And we're talking about just one of those tangent curves. That's all. We chopped it off and threw away the rest of the graph. Okay, now that we have restricted the domains for the three functions, and yes, this passes the horizontal line test, so I'm a happy guy. I know that's going to be true. But now that we've gotten the domains restricted, let's take a look at the inverse functions. Remember, if you switch x and y, you switch domain and range. So before, we restricted our domain from 0 to pi, and we kept the range -1 to 1. Well, that's going to change this, remember? Domain and range actually switch places. So on my graph, what I'm looking for is something, let's see here. The value of 1, think about a circle here, folks. Cosine is 1 at 0. So the cosine of 1 has an angle measurement of 0. Keep in mind what's going on. What's going into the function? These are x values. And what's coming out? Angle measurements. That's exactly the opposite of what we had before when we did the cosine function. We were putting in angle measurements and getting out x values. So here we're putting an x value in and getting an angle measurement out. So if you are making a chart to think about this, the x value was 1, and we got 0 for the radian measure. The x value 0, right, gives me pi over 2. And the x value -1 is giving me pi. So we're looking at a shape that does something like this. This is the inverse, which passes the vertical line test. I'm happy about that. It's a function. Now, how does this relate to the circle? How do you connect this up to the circle? Well, think about the range of the inverse cosine function. 0 to pi. All right, that's the top half of the circle. Almost looks like my dad's comb over. Still don't know why, you know, at his age he's still got that hairdo. Okay, so you might have seen people at parties that, you know, that raise their hands up in the air and they move them back and forth in kind of a swaying motion over their head. They are really referring to the range of the inverse cosine function. I know that probably wasn't running through your mind, but, you know, they're obviously, you know, a little bit more hip on their trig, and now that you're cool and in the club, you know, you'll be able to do that same thing too. So I'm going to ask you questions like this. What's the cosine inverse of radical 2 over 2? Give an exact answer in radians. So you're supposed to tell me exactly, I give you the x value, radical 2 over 2, and you're supposed to give me an angle measurement that has that same x value. Now, here's the kicker. You're only allowed to give me an answer that's between 0 and pi, because the range of the inverse cosine function only goes from 0 to pi. You can't give me an answer that's outside of that. If you do, you're wrong. So let's see here. Radical 2 over 2, it's an x value. That is, let's see here, here's 1/2. Radical 2 over 2 would be next. Oh yeah, that's my 45-degree angle right there. Right. So the answer to this is pi over 4, right? Because give your answer in radian measure. How about my x value, negative radical 3 over 2? Negative radical 3 over 2. Okay, so that's negative 1/2. Negative radical 2 over 2. And then negative radical 3 over 2. That's my 30, 60, 90 right triangle, but I'm over in quadrant 2. And so let's see here. That's going to be 5 pi over 6. 5 pi over 6. How about my last one? Cosine inverse. Cosine inverse of 0. Cosine inverse 0. So there's my x value is 0. Well, that happens to be at the top of the circle, right? So that's pi over 2. Those are my answers for those questions. Okay, let's take a look at the graph of the sine inverse function. The graph of the sine inverse function. So my domain would be the range of the other one, right? Negative 1 to 1. And my range would be the domain of the previous one, the restricted domain. So we end up with negative pi over 2 all the way to pi over 2. Now, what are these? These are y values. And we're getting out angle measurements. Keep in mind, those angle measurements are from negative pi over 2 to positive pi over 2. And we'll look at the circle here in a minute to see how it connects up to the circle. But at least what the range looks like. But let's think about y values here. The y value of negative 1 would be down here. And so that would be negative pi over 2. Y value, if you're making a little chart here, you know, thetas and y's, then let's see here. You're sticking in, you know, I bet that's terribly confusing. Thetas and y's. I hope that doesn't mess you all up. But so let's see here. You are sticking in a y value of negative 1, and you're getting out an angle measurement of negative pi over 2. So negative 1, negative pi over 2. Sticking in a 0, a y value over here at 0. Sticking in a 1, and a y value comes out of positive pi over 2. And so we get a shape, if we plotted more points, that looks like this, which passes a vertical line test, and I'm really happy about that. So the range of the inverse sine function. You might have seen one-arm-handed motions, at parties. Okay. So we're talking about the right half of the circle. So negative pi over 2 to positive pi over 2 over here on the right half of the circle. Every answer that you give me to the following questions has to be between negative pi over 2 and positive pi over 2. It can't be any other values, because those are the only values in the range of the inverse sine function. So let's see if we can kind of, wrong direction. Let's think about this. Sine inverse of 1/2. A y value of 1/2 right here. Dun, 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 dun. Oh, that's the 30, 60, 90 right triangle. And so that would be pi over 6, the 30-degree angle. Negative radical 2 over 2. Okay, so there's negative 1/2. Negative radical 2 over 2 is going to be over here. That's my 45-degree angle. But you can't quote it to me in the positive rotation. You have to quote it to me in the negative rotation, which in this case would be negative 1 pi over 4. Remember your triangle. It's just a 45, 45, 90 right triangle. Sine inverse negative 1, that's a y value of negative 1. Where does that occur? At the bottom of the circle. Don't you dare quote it to me as 3 pi over 2. That is not in the range of the inverse sine function. You have to quote it to me at negative pi over 2. Okay, inverse tangent. So let's see here. The inverse tangent function, we restricted the domain on, so we still have the range from the last one, which was all reals. That becomes the range or the domain of the tangent inverse function. Range would be from negative pi over 2 to positive pi over 2. Not including those endpoints, because those are horizontal asymptotes. When you switch x and y, everything's changing like this. Okay? So you're going to have a picture that does something like this. So the range of the inverse tangent function also sits on this side of the circle. It just does not include those endpoints because those are undefined slopes. Keep in mind, tangents are slopes. So these are slopes, and these that I'm getting out are angle measurements. So you're putting slopes in and you're getting angle measurements out. So let's see if we can handle, oops, wrong direction. My goodness. Frustrating my own self. Negative radical 3 over 3, so that's negative. And the negative radical 3 over 3 was the shallowest slope of the 3. That's the 30, 60, 90 right triangle. So the answer here, since my answers have to be between negative pi over 2 and positive pi over 2, my answer has to be negative 1 pi over 6. How about radical 3? Radical 3 was the steepest. It's a positive, so there's your 30, 60, 90 right triangle. Obviously we can get steeper, but just based on our three main ones that we've done all the work with, that was the steepest of the 3. And so that would be, in quadrant 1, that would be pi over 3, a 60-degree angle. Tangent inverse 1, okay, so slope of 1, right down the middle there of quadrant 1, that's your 45 or your pi over 4. So there's your answer for that one. Now, I've got a bunch of questions that we are going to work on in class. You can try to tackle them on your own, but more than likely you should just copy these down. So I'll zoom in. Okay, these are going to be no calculator questions, and we're going to do these in class, but if you get them copied down, then we'll be ready to go in class, and you won't have to take time. So here are the questions, and I'm just going to kind of go through, and then you can copy them down. Yes, there are a bunch of them. Bunch for cosine, sine, and tangent, and the inverses and all that good stuff. And I know this won't make much sense to you until we start drawing circles and taking a look at what's going on. So just get them copied down, and then we will be able to talk about them in class.